Good morning. Today we are going to discuss about Fourier transform of f of x is equal to 1 minus x square. X ranges from minus 1 to 1 and 0 otherwise. So we have to prove that integral over 0 to infinity sin s minus s cos s divided by s cube cos s by 2 d theta is equal to 3 pi divided by 16. We have to prove that 3 pi divided by 16. Right? So we know that the Fourier transform of f of x can be written as 1 divided by root 2 pi integral over minus infinity to plus infinity f of x into e power I sx dx. Right? So here we are going to substitute our function f of x is 1 minus x square with the limit minus 1 to plus 1. Right? So 1 divided by root 2 pi. And here our limit is minus 1 to plus 1. And f of x is nothing but 1 minus x square into e power I sx dx. So we know that Euler's formula e power I theta can be written as cos theta plus I sin theta. So likewise e power I sx can be written as cos sx plus I sin sx into dx. So next we are going to split up the two terms. So first term is 1 minus x square into cos sx plus second term I into 1 minus x square into sin sx. So here 1 divided by root 2 pi integral minus 1 to plus 1 first term plus, so take I outside from the integral. So I into integral minus 1 to plus 1 minus x square into sin sx dx, right? So now next we have to check which function is odd and even. So square is nothing but positive. If you substitute x as minus x, the function will not change, right? Then cos of minus x is nothing but plus cos theta. So this function also remains the same. Next comes to next function. So here positive and sine function will be negative. Here so plus into plus, this function will be even and second function will be odd function. So automatically odd function integration value will be equal to 0. So we neglect the second term and we write the first term alone. 1 divided by root 2 pi integral over minus 1 to plus 1 minus x square into cos sx dx. Next we have minus 1 to plus 1. So this limit can be written as 2 times of 0 to 1. So this will be equal. So 1 divided by root 2 pi. So instead of minus 1 to 1, we can write 2 into integral 0 to 1. Right? So 1 minus x square into cos sx dx and second term will be 0. So now we are going to integrate 1 minus x square into cos sx by using Bernoulli's method. So first function u is 1 minus x square and second function dv remaining cos sx into dx. So now we are going to differentiate u. So write u dash is equal to, so if you differentiate 1, get 0 minus x square is equal to 2x. So again you differentiate u dash with respect to x, will get u double dash which will be equal to minus 2 into 1. So again you differentiate u double dash with respect to x. So we'll get u triple dash is equal to 0. So next we are going to integrate dv with respect to x. If we integrate dv, we'll get d which is equal to cos sx is nothing but sin sx and divided by the coefficient of x is nothing but s. So next you integrate v with respect to x. So we'll get v1. This will be equal to, so if you integrate sin, we'll get minus cos. So minus cos sx divided by s. So already we are having s, so s square. So again you integrate v1 with respect to x, you get v2 is equal to minus, so cos is nothing but sin, minus sin sx divided by again s square, so now s into s cube. So now you apply this Bernoulli's formula, 1 divided by, so here 2 divided by root 2 pi and u dash v1, u double dash v2. So u is nothing but 1 minus x square and v is nothing but sin sx by s. And minus u dash v1. U dash is minus 2x and v1 is cos sx by s square. So ub minus u dash v1 plus u double dash v2. So 2 into sin sx 0 to 1. So now we are going to apply the limits. So first apply the upper limit. Instead of x, substitute x is equal to 1. So we'll get, so if you substitute x is equal to 1, 1 minus 1 is 0. So 0 into anything, we get 0. So first term automatically 0. Then comes to second term, 2 into 1, 2, cos s into 1, cos s divided by s square. So second term minus 2 into cos s divided by s square, and third term sin 2 into sin s into 1 divided by s cube is nothing but 2 sin s by s cube. So next minus, apply the lower limits instead of x. So first term will get sin 0 value 0. Then second term, if you substitute x is equal to 0 here, second term also will get 0, and third term also 0. So finally we have 2 divided by root 2 by minus 2 cos s divided by s square plus 2 sin s by s cube, right? So next take the LCM. So s cube is the LCM. So this term can be written sin s, and minus here we have to multiply s. So minus s into cos s. This is the Fourier transform of given function 1 minus x square with the limit minus 1 to plus 1.